So today we will be looking into this query. So we have this table, customer transactions, and this table has two columns, customer ID and transaction date. So this data shows the dates on which any particular customer ID has placed the orders. So for example, this customer ID 101, he has placed the orders on date 2026 May 01, the next order on 02, 3, and then 6. And similarly for customer ID 102, we have two orders. For customer ID 103, 5, and then three orders. So what we have to find here, we have to find those customers who placed orders for three or more than three consecutive days. That means if we see for customer ID 101, these three transactions, these are consecutive because the dates are consecutive 1, 2, 3. So these three are consecutive dates, hence customer ID 101 should be in our output. For customer ID 102, we can see that there are only two records or two transactions. So clearly it cannot be in our output. For 103, again we can see that this 1, 2, 3, 4, four transactions are consecutive. Hence this customer ID will also come in our output. For 104, there are three orders, but none of them are consecutive. So this will not be in our output. So 101 and 103, these are our probable customers. Now here we can initially we can think that we can use lead and lag functions on these dates partitioned by customer ID, and we will see that if these two dates are consecutive, then we can see that whether these two dates are consecutive. We can do it when this number, for how many days we have to check whether it is consecutive or not. If it is 2, 3, we can use lead and lag function. But if somebody asks that, we have to find those customers who placed orders for 10 days, 10 consecutive days. So we cannot keep on using lead and lag functions that many number of times. So in such kind of scenarios, we have to use a different approach. So let's see how we can solve it. So we will go step by step. First, what I will do, I need to find out the day part of these dates. So what I can do for it, I will use date part and take the day from transaction date is transaction day. So I can see this day part 1236, 1236. Nothing else. We are just taking the day from this date. This is first thing that we need to find out. Then one more thing that we have to use, which is row number. Row number over partition by customer ID and order by transaction date as RN. So let's see what we can see here. So we can see these dates 1, 2, 3, 4, continuous rank row numbers 1, 2, then 1, 2, 3, 4, 5, and 1, 2, 3. So this transaction day is the day of these dates. This RN is a normal row number. So till now we have not done anything related to this consecutive days. We just calculated these two values which we will be using. So I will put this query in CT, and then let's go to our calculation. Select star from CT. Okay, this is the output so far. CTS. Okay, now here one important logic which will solve our question. So what we will do, we will just find the difference of this day of this date and the row number, and we will name as difference. Now this is the most important thing or the most important logic in such kind of questions. So what we are doing, we are just finding the difference of this day and rank. Why we are doing? Because this day, these are nothing the day of these dates, and this row number are continuous. So wherever these days are continuous and this row number is anyway continuous, you will see that this difference value for all these three records will be same 0, 0, 0. Why? Because these dates are continuous, rank row number is continuous, hence the difference is 0. The moment you see a non-consecutive date, the difference is a different value. 6 minus 4 is 2. For 102, the difference is same, but these are only two values. Hence, this is not eligible. For 103, we can see that these are consecutive days 1, 2, 3, 4 and row number 1, 2, 3, 4. Hence, the difference is 0. This non-consecutive is having a different value. For 104, all are different values. So now we have to just do a count star of these different values, this different column, and see if it is more than 3. Those customers will be in our output. So this simple calculation I will put in CTE2. Now, although this particular difference you can find in this first query also, here also you can put a minus on these two values. But to avoid confusion, I am using a separate query. So let's see, select star from CTE2. CTE2 as and comma. Okay. Now we have to do count star of this. So we will take out customer ID different and then count of star and group by these two columns, customer ID difference. So see, these two customers, if we see 101, 103, this count star of this different. So for 101 it was 3, for 103 it was 4 consecutive dates. For all others these are less than 3. So we just have to find out having count star greater than equal to 3. So see, only two customers, this is what we wanted. Now along with that we can found we can take two more things. We can find out the start and end date on which these consecutive dates started and ended. So what we will do, minimum of transaction date and maximum of transaction date. Its name is first day and this is last day, and this count star is count of consecutive days. So see, for customer ID 1, the count of consecutive days was 3. Let me run this initial query also. So for customer ID 1, we can see that these 3 were consecutive days. So 3 is the count. First day was 1st of May and 3rd of May was the last day. Similarly, for customer ID 103, there were 4 consecutive days. Hence 4 is coming here. First day was 1st of May and then 4th of May. And then customer ID 104 and 102, they don't have consecutive 3 days, and these are not coming in our output. So this is how we can solve this question. The main logic was we find out the day part of this date, then use the row number and the difference of these two values. So any such kind of question where we can see that we have to find something for 3 or more than 3 consecutive